I've been asked by several people that view the videos on the windmill and water pump to send a sketch or make a sketch of the water pump itself. I don't have the talent to be able to do that anymore. My hands don't work as well as they used to, and I can hardly hold a pencil. But I'm going to show you the basic pump itself in this video, and hopefully it'll be enough to describe what's going on and how it works. This is the connecting rod. This is how it's put together. This is a barb fitting for plastic irrigation pipe. It's barbed for to hold the leathers and the washers. I've cut it in half, and this is inserted into this end of the pipe push-pull rod. You have to use heat. I use a simple plumber's torch, or you can use a heat gun of some type to heat the pipe and shove it up in there. Once it's up in there, it really stays. I mean, it's really difficult to get it in there, to get it out. This is, like I said, the coupling. It's used in another place. If you have to join the push-pull rod, which can be any length to the depth of the well and the height of the tower, it could be quite long. So even a 20-foot length of PVC pipe isn't going to be long enough. You may have to join it. The way that I found the easiest way to join it was to heat the ends of the PVC pipe and push it together like this. Once it's together, physically I don't think you can pull it apart without heating it again. So that's important to know. It's important to know that you can make that. Use a galvanized bolt. This is the components of what's inside the pump. It consists of a galvanized washer, a plastic washer of some type. I made this out of cafeteria lunch tray. Just cut the circles out and sanded them down on a drill press. Be sure you bevel all the edges. If you leave sharp edges, it's going to cut these leathers really quick. Use two here. Another leather. Another plastic. Another steel washer. And a galvanized steel lock, fiber lock nut, so that it doesn't come apart while it's inside the pump. And that's it. That's the basic part of inside the pump. The thing to note here is that there's two washers in here. This is so that this piece of leather can lay down fairly flat without being on top of this one, because you haven't got much clearance inside that pump. Once this is put in there, if you make it lay on top of the other one, it's going to make you really tight. Your windmill might not go pump it. Okay, and I'm going to show you the rest of these components real quick. This is the bottom end. This is the suction side. This is a 2-inch check valve on the bottom of the pump. I've put it together like this so that if anything gets sucked up against the intake, it'll still release, and intake will go one way if you plug the other way. I do this because I'm using the pump in a fish pond, and if the fish were to get sucked up against there, it would shut the pump down. 2-inch check valve, 2-inch T, reducer. Under this goes an elbow, another check valve. This is all the discharge. This is discharge right here. This is intake, suction. Okay, you can close nipple all this so that it'll go inside a 6-inch casing. Pretty simple, pretty straightforward. That's the bottom part of the pump. This is the pump body. This leather goes up in here. This was all beveled with a Brummel tool inside this piece here. So that pulls in real easy. You have to use the female sides here because this leather the leathers won't go through a male. So if you get these reversed, you're going to have a real problem. So be sure to get them on correctly. This piece doesn't need to be very big. This is maybe 20 inches at the most. So this is screwed together, this is screwed together, this is screwed on here. Now, your push-pull rod can be any length that you need. Okay? Like I said, it could be up to maybe even 40 feet long. But this is the rest of the pump. This piece screws into here. This piece can be any as long as you need it. Screws together like this. Onto this, depending on how long you make this, you have to put something to support that pump down in that casing. Screwed into this pipe, this is a support. It's a cross, 1 inch cross, 1 inch pipe, 1/2 inch PVC pipe inside. That's the push-pull rod that goes back and forth inside the pump. This was in a 6-inch pipe casing. You drill 2 holes across from each other, shove the pipe sideways, put that one on, pull it this way, put this one on, put 2 pins through on the outside of the casing. That'll hold this in place. This pipe, this piece here, doesn't need to be very long. It can be 4 or 5 feet is enough. It takes it all the way up to where the top end is, but it doesn't connect to anything because the pump is going like this on the top because of the throw of the pump. Okay, I don't know if you can see that. Because of the throw of the pump, the windmill, this piece here is going to rock like this. The other thing that you should be aware of is that not only that, but this piece has to be rotating so that it can go around inside of the windmill can turn it around inside the pump. So it's really a quite simple design. It's pretty efficient. It works quite well. If I push this up and down, you can hear it. It's pulling air right there. So you know it'll pump water. I'll put this all together like this. This is what it looks like. This. This. Now you realize, of course, this isn't going to fit inside that small 6-inch pipe without shortening all this up. And then a hose to the top. And you could tie wrap it to this and to the guide pipe. I think it's pretty simple to do. I tried to save fittings wherever I could, but so I glued it together in places instead of using fittings everywhere. But the more fittings that you use so that you can take it apart to work on it, the better off you are. This piece is all 2-inch up to right here, and then it becomes 1 inch. The reason I did that was that I've used scrap pipe that was around, so this was a piece of scrap, and then this was a piece of scrap also, and it's worked out really well. But if you had to buy it, this would be considerably more expensive than maybe even 20-30 feet of this 1-inch pipe that's going to be down in the well. So, you know, try and cut corners wherever you can. I don't have more than at most $200 into mine. Part of the cost was the check valves, and the rest was the Lazy Susan bearing, 12-inch Lazy Susan bearing, and plywood. That's pretty much it. Thank you.